All right, we're going to get started. Thanks for coming. Little disclaimer about this. So this is a talk that I've been giving for several years. It was put together long before I joined Box, and I'm still giving it because it's still relevant. Therefore, if you see things in here and you're like, oh, he added that because he saw, that's not the case. This content hasn't changed in a while. And I think that's good, so we'll be able to see what goes on in the industry and how we measure up. I've also not edited the slide deck at all from before I joined Box. So there's a few intro slides that say, like, I work at Box, because you didn't know that already. Books, yeah, so Maintainable JavaScript is the book that is based on this talk. There's a couple of copies in the lending library. There's the ebook version that's been uploaded that you can go and grab if you want to learn more. And I hope that you do. Twitter, OK. So maintainability, why do we care? It's funny that engineers don't think about maintainability more. We think about writing code, and we don't think about what happens to that code once we're done writing it. But the fact of the matter is, it's very strange if you're actually writing a lot of new code. Because new code basically means you open up an editor, you press Control-N, although not in IntelliJ, because that does something else. But in every other type of editor, you hit Control-N, you get a blank file, and then you start typing. Right? That's creating new code. Now, you create some new code, you get up, go to the bathroom, grab a coffee, come back. Now you're maintaining code. Okay? It's that same code, but now you're working with existing code instead of creating something from scratch. And that's how we spend most of our time, is maintaining code. We maintain our own code, we maintain other people's code. And so we care about maintainability because that's what we're doing most of the time. And when you're spending most of your time doing something, it's a little bit silly to not stop and think about how to make that easier, how to make it better. And that's what this talk is about. So who cares? One, your company cares. And so you were hired by the company not to create code. You're actually hired to create value. And you're creating value by creating code. But you can also create value by maintaining code. You can create value by giving talks over lunch. You can create value in any number of ways. Now, the point of creating value is that that value sustains even when you're not around. Like, if you go on vacation, you should still be valuable. When you leave the company, your contributions should still be valuable. And that only happens if your code continues to work and people are still able to work with it. So the company cares a lot. Your coworkers care a lot. And so if you've ever had to fill in for somebody who was on vacation when there was a bug in their code, then you're familiar with this. People should be able to understand your code when you're not around. That's what good code is. Good code isn't the code that you need to have the author sitting there next to you to figure out what the hell is going on. That's bad code. So your coworkers really care. And you care as well, because when your coworkers are away, you might have to cover for them. Now, the front end, JavaScript, HTML, CSS, all that stuff is kind of interesting because this sort of stuff is still not being taught in schools. Like one or two, maybe if you're lucky, maybe you learn something practical. But generally, what you need to know in order to work in the industry is not taught in any school. And so that naturally means that the best people at this are self-taught. I taught myself pretty much everything that I know. A lot of the people that you go and see at conferences who are speaking that you think of as experts taught themselves because nobody was there to teach them. And that puts us in an interesting situation. If everybody learns on their own, then everybody comes at it from a different perspective. And everybody has best practices that they think they know, but in fact was just the way that they decided to do stuff. And I liken this to musicians, rock stars. They all start out, they're like not taking any lessons for anything, right? Just start like jamming out and screeching into a microphone. And then at some point they get discovered and publish a CD. And then they actually get signed to a label. And the label comes in and they're like, well, we want you to tweak like this and that. And then rock stars have a fit. Like, don't mess with my process, man. Like, you don't understand. I figured out the way to make my music. And I got to make my music. And you can't get in the way of that, or else what's going to come out is crap. And front-end developers sound a lot like that. They're just like, no, I've been writing JavaScript like since I was in middle school, and I'm not going to change the way that I'm doing it now. And I know how to write CSS. Now, you're the one that doesn't know how to write CSS. I know it way better than you do. But everybody was just taught, self-taught, right? So everybody has their own way of doing things. And that's all well and good until you come to work on a team. Being a part of a team means giving up a little bit of yourself for the better of the team. I like to think of this like an orchestra. We have a lot of really talented musicians, but unless they all decide ahead of time what song they're going to play, how fast they're going to play it, when there are going to be pauses, it's going to be really hard to create really awesome music. And that's what I'm talking about today, is how to work on a team with JavaScript and create really beautiful music. So what is maintainable code? I like to say that maintainable code continues to work for 5 years without major changes. That's usually the point where people's eyes bug out or people walk out because they think that I'm just full of it. Okay, has anybody ever seen code that continues to work after 5 years? Yeah?
It works, but maybe not well.
Okay, so that's the other part of it. So this is one of the things that product and management type people like to call a BHAG, a big, hairy, audacious goal. And it's something that you set your sights on, knowing that you may not get there, but generally feeling like you're heading in the right direction if you try to. And so making sure that your code continues to work for 5 years is something that you should think about. It's not like, is it going to work for this release so that I can move on to something else? It's, is this code good for posterity? Is it going to hang around for a while? Is it not going to break magically? And with JavaScript, things break magically. And that happens frequently because browsers are released every 6 weeks and stuff changes. And if you didn't do your job, if you didn't code things well, then your code breaks. And that happens over and over. And it's happened at large companies. It's happened at small companies. It's happened with major JavaScript libraries, where people were just doing things in a really sloppy way, and a new browser was introduced. And then everybody who's using that library breaks. Right? That's crappy. You don't want that to happen. So I actually, a few months ago, I got an email from somebody from my second job. Now, my second job, I started 12 years ago. And he emailed me and said, hey, I just wanted to touch base because I'm working on your code. Right, so frightening. My code that I wrote 1 year out of college is still running some major sites. But cool. And then I said, you know, it's actually really easy to use and update, and we haven't had any problems with it. And I just wanted to email you and tell you how much I appreciate that. Like, well, that's really cool. So yeah, apparently I reached my peak a year out of college, and I've just never gotten any better. So maintainable code is intuitive, right? You can look at it, you can understand what it's doing without needing to step through the code. Right? That's really important. We're going to talk a little bit about self-documenting code later. But it's really important for you to be able to just gaze over the code and kind of have an idea about what it's doing. It should be understandable. So that means when you actually start to scratch the surface and look at it in a debugger, step through, it still makes sense. It's adaptable. So that means that you can change it a little bit. It's not going to break. You don't want brittle code. You want code that you can make small changes to it and it will continue to work. You want extendable. So whenever possible, you should think about how your code might be used in the future and plan for that sort of extension. So when you extend something, you're adding on something that nobody really thought of at the beginning. And so when you write code in a maintainable way, you plan for that. You know up front that you didn't guess correctly. You don't know exactly what all of your code is going to do, and so you leave yourself some leeway to make changes. And debuggable. So you want to be able to find errors in your code easily. You don't want it to be a mystery whenever an error happens. And of course, testable. You want to make sure that you can run some automation against it and just have a sanity check about what you're doing. So Chris Epstein, who's the creator of Compass, did a really great talk. And one of the quotes that I took from that was, be kind to your future self. The person who may be maintaining your code might be you. It might be the code you wrote last year or 2 years ago. And your brain cannot hold that amount of information for that amount of time. You will forget. So as you're writing code, if you go through and think like, whew, I may not remember this next year, it's probably a good place to throw in a comment or write some documentation. So let's talk a little bit about code conventions. Code conventions are really made up of two things. There's code style, and that's basically syntax. And then there's also programming practices, so small design patterns to solve common problems. We're going to talk about both. So code style guide is really important. Figuring out how you're going to write code as a team is probably the most important thing you can do. And the reason for that is that code is not a mechanism for machines to do stuff. Code is a communication mechanism between people. It's the way that we communicate with each other each and every day, even when you don't see people face to face. And if you were trying to talk to everybody in the room and everybody spoke a different language, it would be really hard. And that's what happens with code style. Right? Unless everybody is doing the same thing, it's really hard to communicate to one another, because you don't always have the opportunity to sit down with the person who wrote the code. Either they're not there anymore, or they're just not there for that day, or they're just super busy and they don't want to deal with it. So if you think about code as a communication mechanism, you realize that how you write the code, not just the fact that it works, but actually how you think about structuring it, how you write the syntax, matters. This is one of my favorite quotes from the Structure and Interpretation of Computer Programs. Programs are meant to be read by humans and only incidentally for computers to execute. Computers couldn't care less as long as the syntax is correct. But as a human, you have to be able to read that code. And people will appreciate it when you write nice code. So this is my buddy Tom. He's the CTO of choice.org. And we were kind of going back and forth about coding style on Twitter. And he tweeted this at me. "I'd like to stand beneath people's bedroom windows and read your code aloud." That made me feel good. So there are a bunch of stuff for JavaScript that's already out there. Doug Crockford has a code conventions for the JavaScript programming language. Google has a JavaScript style guide that they've published. jQuery has a core style guide. Dojo has a style guide. There's also this project called idiomatic.js, which is a style guide that's been like crowdsourced for interesting patterns. Now, in conversations about code style, there's bound to be fights. Bound to be fights. Because again, everybody's coming from a different perspective. The way that I grew up writing code is the way that I want to continue writing code. And if you are going to try to change that, I am going to yell and scream and throw a fit. Right, so I've been in these conversations before. Right? Like indentation, I was actually once in a half-hour conversation about indentation. Half hour. Just to figure out not whether tabs are spaces, because we agreed pretty quickly that it was going to be spaces, but how many spaces. That's what took 29 minutes. How many spaces for indentation?
What did you settle on?
We settled on 4. And that was only with an agree to disagree situation. And that's what you have to do, is you have to get to some point where you just say, you know what? We both have really strong opinions about this. Neither one of us is right. Right? It only matters that everybody does the same thing. So if you think about it, it doesn't matter what side of the street that you drive your car on. No, as long as you're driving on the same side as everybody else. And so if you go to England, it's completely fine. They're driving on the left side. A little weird. But technically, there's nothing right or wrong about driving on the left or right side of the road, except that the right side is clearly the right side. It only matters that everybody's doing the same thing. So if you've been developing for longer than 2 months, you've probably opened up a file that looked like this. And then before you did anything, you re-indented the entire file. Because you can't work like this. This is crazy. Right? And that's because people weren't following the same indentation style. Right? And that's really dangerous, because you go and you try to work with code, and you're like, OK, so we have if, we have else. All right, that looks OK, except that the else does not go to that if. It goes to the third one, which you figure out after you indent. Right? Big pain in the ass. So figure out what that is. The less code on one line, the less likely you are to encounter a merge conflict. Seems logical, right? But be surprised, like, there seem to be in the industry, I don't know how this happened, people who pride themselves on getting as much code onto one line as possible. And I don't know if that's so that later they can be like, well, my program runs in 2 lines of code. Like, well, yeah, but your 2 lines are each 20,000 characters long. So that doesn't really count for anything. Right? It sucks. And so the fewer things that you put on one line, the less likely you're going to run into trouble. So yeah, this sort of thing, hate that. This, I can breathe. So now if you make a change, you can actually make a change on a line, and it's a lot easier to figure out. Also, yeah, comments. So comments are interesting. I haven't met many developers who like to write comments, because comments start to cross over into that dirty realm of documentation. And developers tend to hate writing documentation. I'm not entirely sure why that is. I suspect that it's more fun to write code than it is to write documentation. I don't know. As somebody who writes a ton, I'm probably not the best person to speak on that. But there's no such thing as self-documenting code. It's a myth perpetuated by people who hate writing documentation. So it usually goes something like this. Well, if your code is clean, you should be able to just understand it. So no, that's not the point. The point is you shouldn't have to step through a debugger to figure out what this code is doing. You shouldn't have to go through each line to figure out what this code is doing. Most of the time, you don't care at that level of detail. You just need to know at a high level, what is this method doing? How is it doing it? Oh, OK, I don't need that method. Or yeah, I do need that method. Right? No such thing as self-documenting code. So what do you comment? Every method. Right? Tell me how I'm supposed to be using this thing. I need to know what it does, the inputs, the outputs. Any code that's difficult to understand. So if you look at code and you think, whew, it's a good thing I have all that in my head, you need to add some comments. So this is actually from the YUI library. And it's a great example of you having no idea what the hell is going on if those comments aren't there. Because every single one of these case statements does a mix, but it's doing mixes with different things, right, based on the mode. And you would have no idea what that was unless those comments are there. Question? You can ask a question. Is there another one?
I often feel that if you have comments that are like rather long or even there at all, that often means that there's some ambiguity in the code. And that sometimes it's better to figure out why the ambiguity is there, like what necessitates that comment, and then think about if I wrote the code differently, like if I name, instead of having case 1, it's case proto to proto, then like you wouldn't need that comment. I just wonder what you think about that.
Yeah, so the comment was, usually when you see a long comment to explain some code, that might be an indicator that the code is just a little bit too complicated anyways, and you may want to go back and refactor it. I agree. If there's some way to make the code easier to understand, then you should. But you also should not be afraid to put in some comments. If you reach a point where just like, look, so I'm not an algorithms expert. I tell people that straight out. If they start talking about, sort this and do what my eyes glaze over, I'm done. But most of the time, I don't need to know how those work. However, if you're writing a function that's implementing some well-known algorithm, you probably want to include a little more verbose comment in there so that somebody who's reading the code knows where to go for more information. I'm very against commenting every line of code. But if ever there's any ambiguity, and sometimes you can't get rid of ambiguity, unfortunately, then throw a comment in there. I'll take the hit for that. So code that might seem wrong, this is one that people miss a lot and that causes a lot of problems. So developers are well-meaning. When we go in and look at code, we want to make it better. Okay, I'm going to take that as an assumption that we all want to do that. So you go in there and you come across some code and you're like, oh wow, this person made a mistake. I'm going to fix that. So in this case, it's not typical to put a single equals, an assignment, in the control condition of the while loop. Right? It's not that it's illegal, it's just not usually done. And so if you were going in and looking at this code and that comment wasn't there, your first thought might be, that looks a little weird, there might be a bug. I'm going to fix it by making that a double equals. Right? But in fact, you've now introduced a bug because you didn't understand what was going on there. And this is a trap that we fall into as JavaScript developers a lot because browsers do such weird and quirky things. Something might work fine in Chrome, and then in Firefox it doesn't work that way and you have to do something else. And somebody coming into the code may go like, oh, that should work in both browsers. I'm just going to combine those two together. And now you've introduced a bug. So if there's something that you're writing that looks like it might be wrong to somebody else, you just throw in a quick comment. I intended to do that. It's completely intentional. It's not wrong. In fact, if you change it, you will make it wrong. Really important. So naming. Love me some naming. So use logical names for variables and functions, and don't worry about length. You don't win a prize for creating the most concise code. You may win a prize for creating the most maintainable code, if I have anything to do with it. So variable names should be nouns. Right? We'd like code to read like a story. And in order to do that, when variables are nouns, you can actually read the story. Function names tend to begin with a verb. So again, you want the code, when you read it out loud, to sound like a sentence. If I am getting name, got it. And then a little additional thing for booleans, can change that to like is, has, something that indicates it may actually be returning true or false. Always nice. Avoid useless names, for God's sake. Foo, temp, all of those, completely useless. I have no idea what you're trying to do, no idea what you're storing, no idea how I should use that thing. All right, so this code I showed you earlier, it's an indentation example. No clue. This was written by a human. This is not minified code. It was written by a human, and I know that human. I will not talk to him in the streets. It just makes your code really hard to deal with. Right? Nobody has any idea what's going on except for him. Right? All right, camel casing. JavaScript default. Let's do it. So here's a fun one. So you have camel casing. What about acronyms and abbreviations? Things that are you would say in a sentence as just all capital letters. How do you deal with that? Well, it's hard because if you look at JavaScript, it's very inconsistent itself. So we have getElement by ID, right? ID. I, capital I, lowercase d. GetElement by id. ID. Inner HTML. capital HTML. Right? Internally inconsistent within the language itself. Even better. Right? So yeah, the XML, that's clearly something that should be all uppercase. But the HTTP, I'm not really sure. Maybe we should go with lowercase of that. I don't know. But this is just, everybody has trouble with this. Does it matter? No. You just be consistent and do it the same way all the time. Yeah, so some exceptions usually do constant-like variables like this, all uppercase with an underscore. That's kind of carried over from the C days. Constructors, so anything you're using new with to have a capital letter.